Okay, this is Unit 5, Moles and Stoichiometry, and in tonight's lesson we are going to learn how to balance equations. A chemical equation is a set of symbols that state the product and the reactants in a chemical reaction. And we've already talked about the products and the reactants in different lessons before. The reactants are the starting substances in a chemical reaction, and they're always found to the left of the arrow. While the products are a substance that is produced by the chemical reaction, and they are always found to the right of the arrow. So in looking at the reaction below, sodium and water are my reactants because they are to the left of the arrow, while sodium hydroxide and hydrogen gas are my products. Chemical equations must be balanced. And what I want you to do is think of the arrow as an equal sign. So what we have on the left of the arrow must balance with what we have on the right of the arrow in terms of the number of atoms of each element that's present in the chemical equation. The law of conservation of mass tells us that mass can neither be created or destroyed. So what we start with, we must finish with. It can be rearranged into a different substance, but we still must wind up having the same amount. So the number of moles of each substance on the reactant or left side of the equation must be the same as the number of moles of each substance on the product or right side of the equation. The coefficients and the subscripts tell us how many moles we have of each element. So up here when we're talking about substance, substance equals element. So let's look at this balanced equation below. Notice that there is 1 mole of carbon, so there's an unspoken 1 right here, and 2 moles of oxygen. You have 2 oxygens on each side of the arrow. So I have 1 carbon, 2 oxygens, 1 carbon, 2 oxygens. So this means that the equation is balanced. Now, one thing that I want to point out, when I have a number in front of an element or a compound, this is the coefficient. If I have a small number within the compound, this is referred to as the subscript. Let's examine the following unbalanced equation. How does this unbalanced equation violate the law of conservation of mass? Well, let's look. I have 2 H's on the left, I have 2 O's on the left, and then on the right I have 2 H's and only 1 O. So I'm violating the law of conservation of mass because I'm not finishing with what I started with. So in this equation, oxygen would have had to have been destroyed because there is less oxygen on the right side, which is impossible. So the coefficient, as I just told you on the previous page, is the integer in front of an element or compound. which indicates the number of moles present. The subscript is the integer to the lower right of an element, which indicates the number of atoms present. And species, and you've heard me use this word before, equals the individual reactants and products in a chemical reaction. So although we know that this is hydrogen gas, I can refer to this as a species. The same with oxygen or water. So what do we use to balance equations? We use coefficients. That's the only thing that we can change when we balance an equation. We never ever change the subscripts, because if we change the subscripts, we're changing the formula. So in this example, we have a coefficient of 2 in front of the silver, a coefficient of 1, it's unspoken, in front of the S, and a coefficient of 1 in front of the silver sulfide. For our subscripts, we have a subscript of 1, it's unspoken. For the S, a subscript of 1. And within the silver sulfide, we have 2 silver and 1 sulfur. So let's look at the rules for balancing equations. First, you're going to draw a line to separate the products from the reactants. So A plus B yields C plus D. Draw a line. And then you're going to list the different elements, and you're going to write how much you have of each. Count up the number of atoms on each side and record it next to the symbol. We did that. Find the most complex compound in the equation and balance those elements first. Every time you change a coefficient, you have to update the number of each element, and you're going to continue doing this until you've balanced the equation. So let me show you a couple of examples. Here I have 2 H's and I have 2 O's. On the right I have 2 H's and I have 1 O. Well, here's the problem. I have 2 O's and 1 O, so I need to put a 2 here. When I do that, this now becomes 2. But I've also affected these H's. 2 times 2 is 4, so I have 4 H's. So my O's are balanced, but I have 4 H's, 2 H's. If I put a 2 here, I now have 4 H's. And now my H's are balanced. So my balanced equation is 2H2 plus 1O2. I don't have to write the 1, it's unspoken, plus 2 waters. Okay, 2 more examples and we're done. Na, I have 1, H, I have 2, and O, I have 1. Na, I have 1, H, I have 2 here, and 1 here is 3. And O, I have 1. So my NAs are already balanced, my O's are already balanced, but there's a problem with my H's. And you'll find that when you have an uneven number, the first thing you want to do is kind of even it up. So if I put a 2 in front of here, I'm going to have 2 times 2 is 4, plus the 1 here is 5. That's not going to even up the playing field. If I put a 2 here, I have 2 H's here, 2 times 1, 2 H's here, and 2 H's here is a total of 4 H's. Now, I need to make sure I have 4 H's over here. So if I put a 2 here, that gives me 4 H's. But I've now just changed my oxygens. I have 2 oxygens here, but when I changed this over here, I actually changed what else? When I changed these hydrogens, I changed my Na to 2, and I changed my O to 2. So now my O's are balanced, my H's are balanced, and I can put a 2 here, and my NAs are balanced. Let's double check. 2 Na, 2 Na. 2 times 2 is 4 H's. 2 times 1 is 2 H's here, plus 2 more H's there is 4 H's. And 2 times 1 is 2 O's, and 2 times 1 is 2 O's. Last problem. C, I have 1. O's, I have 3. 2 here and 1 here. And H, I have 2. Carbon, I have 6. O's I have 8, 6, and 2, and H I have 12. So let's start with the carbons. 6 and 1. Well, very easily I'll put a 6 here. That changes my oxygen though. 6 times 2 is 12, plus 1 is 13. Next thing I'm going to look at is my H's. And the reason why I'm skipping the O's right now is because O's are in two different places. When you have elements in two different places, it's a little bit more difficult. But H is only in one place. So I've got 12 H's here, and I only have 2 here. So if I put a 6 here, 6 times 2 will give me 12 H's. But now I affected my O's. 6 times 1 is 6, and 6 times 2 is 12. So 12 and 6 is a total of 18. So now my C's are balanced, my H's are balanced, but I need 18 O's. Well, if I have 6 O's here, and I need 12 more, I can put a 6 here. 6 times 2 is 12, plus 6 there is 18. And now my equation is balanced. Okay, that's it. We'll spend some time in class working on these.